Today we will be looking at multiple representations of slope. We will be looking at 4 different ways to find slope from various information given to us. We have this foldable. This is the outside. This will be the inside. We're going to fold these flaps in to make windows. Just crease those. And then this will tell us the 4 different ways that we're going to find slope. So what we have here is slope from a graph, finding slope from 2 points, finding slope from an equation, and finding slope from a table. So let us start with finding slope from a graph. So we're going to open up our foldable. We're going to look at this top section here, finding slope from a graph. I'm going to zoom in so that you can see this a little bit better. There we go. So what we're going to do here is look at 2 points that are on the graph, and we're going to count how we move to get from one point to the other. So here's a nice point here. Here's a nice point here. Remember that slope is change in y over change in x. So what I have here is a positive change of 3 and a positive change of 2. So slope is my change in y over change in x, or called delta y over delta x. And that is going to be a delta change for y of positive 3 and a delta change of x for 2. So our slope then is 3 over 2. Okay, now finding the slope from 2 points, we are going to be using our formula, and that formula is that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the first thing we need to do is identify our x sub 1, x sub 2, y sub 1, y sub 2 in these 2 points. Every point is always in x and y. So this is our first point, so this is x sub 1. This is our our first point, but this is the y value of our first point, so we have y sub 1. This is the x value of our second point, so it is x sub 2. Y value of the second point, y sub 2. We will use our skeleton for the slope formula and substitute in the values that we need to find the slope. So the y sub 2 is 7, so we replace that area with 7. Y sub 1 is negative 4, so we put the negative 4 inside the parentheses. X sub 2 is a 2. And x sub 1 is a negative 2. So again, the negative goes inside the parentheses. And these right here are subtraction. In your calculator, you would use alpha y equals, enter this numerator in, arrow down, enter the denominator in, and press enter, and it will give you the fraction in reduced form. But we don't have that available to you at the moment, so we will just do this old school. 7 subtract negative 4 is the same as adding 4, because subtracting a negative is the same as addition, so we end up with 7 plus 4, which is 11. And then on the bottom, subtracting a negative 2 is the same as adding 2, so we have 2 plus 2, which is 4. So we end up with m, or the slope, being 11 over 4. So that's from a graph by counting and given 2 points using the formula. We have 2 other ways to find slope. One of those is from the slope-intercept form of an equation. This is our slope-intercept form of the equation. The number in front of the x, or the coefficient of x, is your slope. The constant term is your y-intercept. So in this equation, the 3 would be the slope, and the negative 5 would be the y-intercept. So let's look inside here. We have 3 examples. We will go ahead and write down the slope-intercept form of the equation. under each of these. Okay, so we have y equals mx plus b. So all we do then is just line it up. Y equals mx plus b. So that means that in this case, m is going to be negative 1/2 because negative 1/2 is the coefficient of the x term. In the second equation, we have 5/4. And the slope is then going to be 5/4 or 5/4 because 5/4 is the coefficient of x. In the third example, the coefficient of x is the 2, so our slope is just 2. We don't need to write it over 1 when we're identifying it. The final way that we can find slope from a table is by using rate of change. We're going to look at rate of change. So what we do then is we look at how the x changes and we look at how the y changes. 4 minus 2, we take that difference and we get 2. 6 minus 4, we take that difference and get 2. 8 minus 6, we take that difference and again get 2. So these are our differences or our changes in x. Our changes in y, -5 minus -3. So a -5, we are subtracting a -3, so we are still going to end up with a -2. We have more negatives than we would have positives in that case. -7 subtract -5 is like -7 plus 5. We still end up with a change of -2. -9 minus -7, again, we end up with a -2. So these are our changes in x. These are our changes in y. So slope as rate of change is change in y over change in x. So our slope then would be -2, since we had a change in the y column of -2 each time. And over here for the change in x, it was a 2. And then we simplify that. -2 divided by 2 is -1. You could also use 2 of the points that you're given here and use the slope formula as well. That's another way to find slope from a table. But remember that rate of change and slope are the same thing. So let's just go ahead and choose 2 of these points. 2, -3, and we'll just go with 4, -5 to show that we're going to end up with the same slope. Identify your x sub 1, y sub 1, x sub 2, y sub 2. We know that the formula was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We write our skeleton. I know this is a little small. Hopefully you can see it. We get a -5 for our y sub 2. We get a -3 for our y sub 1. X sub 2 is a +4. X sub 1 is a +2. A few moments ago up here when we were looking at the change in y, we did -5 minus -2 and got -2. So this result here is -2, and of course 4 minus 2 is 2. Simplify that and you get -1. So it doesn't matter if you put it choose any 2 of these points, put them into the formula, you are still going to end up with the same thing as if you looked at common differences here on each side. What are their differences, and then what is the ratio of those differences? Does -2 over 2 give me -1? And this ended up being -2 over 2 each time. So that ratio did reduce to -1, so we end up with a slope of -1. Now inside the foldable, in the middle, we have a word problem. Let me back this out a little bit. Dealing with the population of toads. So it says currently there are 200 Houston toads in Bastrop County. The Houston toad population has been decreasing at a rate of 20 toads per year. So we need to identify what X represents and what Y represents. Our X value is going to be the years. This is independent. Each year, what is the change going to be? Since this said per year, that means we're changing per year, so that's why X is year. And then our total number of toads, we'll just say number of toads. Since we are decreasing at this steady rate, the number of toads per year decreasing, but that amount each year is Y. How many are left is Y. So it says to write an equation that models this linear relationship. So our total number of toads that are left in a year can be found by taking the initial population and subtracting 20 toads per year. And it wants us to identify slope and the y-intercept from the equation. In order to do that, I'm going to rewrite this in proper slope-intercept form. So we have y equals, and we put our x term first, and remember the sign in front of the number goes with the number, so we get minus 20x or negative 20x, and this being a positive, we don't always write down the plus sign, but we need to in this case. So we have y equals negative 20x plus 200. The slope is the number that is in front of the x, that is its coefficient, so m is going to be equal to negative 20. Then we have our y-intercept. The y-intercept is that initial starting point right here. This is our y-intercept. Okay, so we had y equals m times x plus b. B is your y-intercept. This is your slope. So here's our y-intercept, and then we can say that 200 equals our y-intercept. Okay, it says to make a table of values and then identify the rate of change that is in the table. So we are going to count by, well, I'm going to do some different things here. Okay, we have x and we have y. And I'm not going to count by ones or count by twos. I'm going to pick some specific values for x of 0, 1, 5, and 6. The y values for these, because I went into y equals and put this into the calculator and did second graph to look at a table, and I just chose some specific values to show you about rate of change. And notice how we did not count over here in the x column by ones. I just pulled out some random numbers. So what we do here is, again, like we did on the finding slope from a table. So let me go ahead and finish out making the table. We're going to look at how the x values change, how the y values change, and then we're going to look at the ratio there. This is a change of positive 1. This is a change of positive 4, and here we have another change of positive 1. Go ahead and make that just a little bit bigger for you. So this was our delta x. Then we can find our delta y, the change in y. From 180 minus 200, this change right here was a decrease of 20. The change from 180 to 100 was a change, or sorry, decrease of 80. And then from 100 to 80 is again a decrease of 20. So what we want to do there is look at the ratios here and see if they will all simplify to the same number. So we have delta y over delta x, delta y over delta x. Here, negative 80 over 4. And then once again, a negative 20 over 1. If I take negative 20 and divide it by 1, I'm going to get negative 20. If I take negative 80, divide it by 4, I'm going to get negative 20. If I take negative 20 and divide it by 1, I'm going to get negative 20. We have what is called a constant rate of change, so our slope is rate of change. Do you see how that our constant rate of change matches our slope that we found from the equation? Now we're going to graph the equation. So this is our x-axis, this is our y-axis, and the first thing I'm going to do is graph the y-intercept. So back up here with the slope and y-intercept, I need to graph that, but I'm not quite sure where to graph it because I haven't labeled anything here. So I'm going to go ahead and count by 40s on the y-axis to make sure that I can get all the way up to 200. So 40 plus 40 is 80, plus 40 is 120, plus 40 is 160, plus 40 is 200. On the y-axis, we'll go ahead and count by 2's, but I'm only going to label every 4. So there's 2, 4, 6, 8, 10, 12. So we can go ahead and start graphing with the y-intercept here at 200. This was the initial start of the population. This is where they started counting and seeing what was going on. So over here at 2, after 2 years, we've had a 40 toad decrease, so we get to 160. Then we go to 4, and that's going to give us 120. Here is 6, and that's going to give us 80. 8 will give us 40. And finally, 10, which is 2 years later, is going to give us 0. So we have gone from 200 toads losing 20 a year. We have the graph being a negative slope. We find that our intercepts are where they cross either the y or the x-axis, and we'll identify our x-intercept as 10. So that would be 10, 0. The x-intercept is also called the 0 because that's where y equals 0. And in 10 years, what this tells us that in 10 years there will be no more toads. So after 10 years decreasing 20 toads a year, they're going to end up after 10 years of not having any toads at all. The y-intercept up here, this is where the x value is 0. So before we started counting, there were 200 toads. And the 200 represents the initial so the 200 is the initial starting population. Okay, so our x-intercept is where the graph comes down to 0, and that is at 10, and so then 10 years the total population will be 0. It started out at 200, 10 years later it is 0. Now it asks us to choose 2 points from the table or graph and solve for slope using the slope formula. So let's go ahead and choose our intercepts. We'll use those. We'll have our y-intercept when x is 0, y is 200, and our x-intercept when y is 0, our x is 10. We will label x sub 1, y sub 1, x sub 2, y sub 2. Remember, we have our slope skeleton that we need to build. And y sub 2 is 0, y sub 1 is negative 200, x sub 2 is 10, x sub 1 is 0. So this will give us a slope of negative 200 over 10, which will then reduce to negative 20. This is when a calculator definitely will come in handy. So our slope ended up being negative 20. So to recap, we looked at 4 different ways to find slope from a graph, from an equation, from 2 points, from a table as rate of change. And then we applied that information in our word problem. Thank you for your attention. Have a great day.